Hi, today we are going to explain about laminar flow and turbulent flow. First of all, in fluid analysis, many materials such as milk, juice, and sauces are fluids that need to move through pipes or equipment. The way these fluids move is called fluid flow. Understand fluid flow is important to control processes like mixing, heating, and measuring in food production and analysis. There are two main types of flow. First is laminar flow and second turbulent flow. The type of flow depends on the speed of the fluid and its viscosity. In food analysis, knowing whether the flow is laminar or turbulent helps ensure accurate and consistent results when testing or processing food samples. Next, the objective of laminar and turbulent flow to understand the different types of fluid flow, laminar and turbulent, and their characteristics in fluid analysis process. To identify how the type of fluid flow affects the accuracy, efficiency, and quality of food testing and processing. First, let's understand what fluid flow means. Fluid flow is the movement of fluids, which can be a liquid or gas from one place to another. This movement happens because of pressure, difference, gravity, and external force. In simple terms, fluid flow describes how fluids move, either smoothly or irregularly, through a pipe, channel, or open space. Examples of fluid flow include water moving through a pipe, air flowing in a ventilation system, or even blood flowing through our veins. Next, let's look at laminar flow. Laminar flow is a smooth and orderly type of flow where the fluids move in parallel layers. Each layer slides past the other without much missing. This kind of flow usually happens at low speeds with thicker fluids like oil or honey. It is also characterized by a Reynolds number less than 2000, which means the flow is steady and predictable. On the other hand, turbulent flow is the opposite of laminar flow. It's irregular and chaotic, with fluid particles moving in many directions. This causes free motion and mixing within the fluids. Turbulent flow usually occurs at high velocities or less viscous fluids, like water or air. The Reynolds number is greater than 4000 and energy loss due to friction is higher. A common example is the fast moving in a river or air flowing around an airplane. To summarize, fluid flow refers to how liquids and gases move. Laminar flow is smooth and steady and orderly. Meanwhile, turbulent flow is chaotic, fast and full of moving. So next I will explain the important laminar flow to food industry. First, laminar flow is important in the food industry because it allows smooth and gentle movement of liquids, helping to maintain the texture and the quality of the liquid product like creams, sauce, and yogurt. It also keeps the air clean in processing and packaging areas by preventing dust and bacteria from contaminating the food, ensuring hygiene and product safety during production. So next, I will explain how important turbulent flow to food industry. Turbulent flow is important in the food industry because it helps mix ingredients evenly, making the product more uniform. It also improves heating and cooling during process like pasteurization and refrigeration. Besides that, it keeps solid particles from settling in liquids and help gases or liquids spread faster in processes such as fermentation. Overall, turbulent flow makes food processing faster, more efficient, and ensures better product quality. That's all. In conclusion, this experiment successfully demonstrates the basic principle of fluid flow, highlighting the difference between laminar flow and turbulent flow. Through this study, we gain a better understanding of how fluid behave, change with flow rate and viscosity. These concepts are highly relevant in various real-world applications, especially on food industry, where controlling fluid flow is essential of processes such as mixing, heating, and product consistency. Overall, this experiment deepens our knowledge of fluid dynamics and is significant in ensuring efficiency and quality in industrial operation. That's all from us. Thank you for listening.